Good morning, Moti.
Morning, Ron.
Happy to have you here. It's my big pleasure to be at the booth of Valens and learn more about the technology that Valens is offering to the machine vision space. I see that's a new asset, right? A new innovation, and I'm always curious to learn more about it. So maybe, Moti, shall we start off with where is Valens coming from? So can you give a little bit of background about the company?
So Valens is a semiconductor company. We do high performance connectivity, and our older legacy business is mainly for the professional audio video market. Mm-hmm. We have a chipset that is used for extension of high performance video, HDMI, USB audio controls for many types of applications. You can find Valens technology in meeting rooms, in signage, in medical. We have high performance connectivity in cars, into Mercedes cars. They use our technology for high performance connectivity. Mm-hmm. We are also in the industrial market. We have customers like Siemens, B&R, Beckhoff that use our technology for human machine interface extension to have control from long distance on industrial PCs.
Wow. Okay. Well, that's a wide spectrum of activities. So, I hear you are apparently coming from this audio, video, and automotive space, and that's interesting because we have seen it a couple of times lately that very mature technology from adjacent application spaces have now been migrating into the vision space.
Yeah.
So like the image sensor technology, right, and the lighting technology with the outside lighting, real lighting of automotive lights that's been now making its way into machine vision. So it's lovely to see that this is now happening also in the connectivity space. Apparently, what is the technology about? Let's say what does it solve? What problem does it solve?
So if I start with automotive, obviously you need very high quality, reliable, low cost connectivity for cameras inside the cars. You can see that the number of cameras is increasing all the time.
Yeah.
And we think that it's the same challenge also in the industrial vision. And why not to take this technology from the automotive and use it for the to solve pain points in the industrial market.
Okay, so it's about connecting cameras, or let's say single cameras and multiple cameras, to a processing unit in a let's say in a high speed way, or let's say what are the assets, so to say, that Valens technology brings to this connectivity?
We are a company of connectivity, so obviously we do high speed connectivity in very low cost cables. What we bring to the industrial market is a better way to connect camera, lower cost, thinner cable, more challenging type of links, and cameras can become much simpler and smaller. You have the same challenges also in the industrial market.
That's right. Cameras have to become cheaper, right?
Yeah.
Cables have to become cheaper. The total system costs need to go down, and that's what your technology allows.
Yes.
So that sounds almost too good to be true. But let's say, can you give a little bit of idea how it is done? Let's say, what is the secret sauce there?
Maybe I should start with the fact that the chip is based on a new standard, the MIPI Alliance A5 technology.
Okay.
And MIPI Alliance, when they decided to standardize the connectivity for cars, the target was mainly for the automotive. They saw the problem of ecosystem in cars. It's a big market, and there is a need for ecosystem, multiple companies that will do chips, and the ability to connect between different companies.
Okay.
And so what we bring here is first the fact that it's a standard that is being used in the automotive. You can use it also in the industrial market.
Space. Okay. You are using the MIPI standard, and you're applying that MIPI standard, so to say, on an automotive PHY infrastructure, architecture, so to say. And this enables then robust transmission, high-speed transmission, and when you say high-speed, what does it mean? Let's say what's the bandwidth, so to say, that your technology can cater
Yeah,
to?
so the technology, the MIPI A5 was defined with the roadmap up to 32 gigabit per second. The
Wow,
Valence chipset can support up to 8 gigabit per second of data extension over low-cost coax. When I say low-cost, for example, if you compare it to the coax-press cables, this is much cheaper type of cable because the main use is for the automotive, and we take it from the automotive. We can also support 4 gigabit per second over unshielded twisted pair to a distance up to 15 meters.
15 meters, okay.
The link is very robust, very reliable, high immunity to EMC.
Okay.
We have diagnostic capabilities that could be very useful to ensure 24/7 operation in the industrial market, and maybe a little bit more about how we do it. So Valence choose to implement MIPI A5 using a DSP inside a chip, which makes the link even more robust than other solutions in the market. The DSP is capable of adjusting to the best performance continuously.
When you say more robust, that means in EMC perspective, from your EMC perspective.
Yes, EMC, for example, if there is a very strong noise which is introduced to the wire, the DSP can eliminate the noise, ignore it, and take only the data part of the data part that is received by the chip.
Basically, that's helpful. I can assume in let's say robot applications where you have big robots with strong motors which are generating a lot of EMC disturbances. So your link would be robust against those, I understand.
Yes.
Yeah.
So you get very thin cables, still very robust. Again, as I said, there is also an option to work in using a UTP cable. And again, this is because of the powerful DSP that we have. And there is another mechanism that makes the MIPI A5 very reliable. It's a retransmission mechanism which was defined by the standard, which means that errors are being corrected between the two chips. The user or the processor will not get any error. And so this is another mechanism that helps first to get more reliable link, and second, use this information to identify when is the point that you need to maintain the cable. If you see that the retransmission is getting higher and higher every day, that's the point that you need to replace the cable.
Okay. With the Valence technology, I can simplify the design of the camera itself and just integrate this DSP, so to say, in the camera, maybe instead of the expensive FPGA, right?
That's right.
And what I get is high transmission rates, robustness against EMC, cheaper cabling. Okay, and this applies, I assume, as well in, let's say, large vision systems where you have long distances between the cameras and the processing unit. But it would also be helpful in a smaller devices, right? So like AMRs, for example.
If you look at the industrial standards that are the most popular today, it's Quaxpress, Gigi Vision, USB Vision. They all rely on expensive FPGA, which means that the camera is much more expensive. The thermal, the heat dissipation, the size, the actual size of the camera is much bigger. A5 optimizes all of that, and as you said, it can fit a lot of types of applications. You talked about AMR. We can use very low-cost cables inside the AMR. Think about drones that you need cables that should be very lightweight, and we have the ability to go over microcoax. Another example would be the ability to go over slip rings. So places that you need 360 rotating camera or even gimbal type of applications, the slip ring could be the best option without dealing with cable aging and making the product very reliable.
Okay, amazing. Thank you so much, Moti. I think that was a great example, and we're always happy to see new innovations making their way into the machine vision space, so that the whole community can benefit from them. And I think what you're proposing is, or what you're providing basically is really a great asset to solve a lot of problems in the cost space, in the connectivity space. So I'm looking forward to hear more about it. So where would customers or people who are interested in that learn more?
You can go to our website and get more information, and contact us through the website and get more information to start your design with MIPI A-PHY in your industrial application.
Okay.
Thank you very much.
Yeah. Thank you. Thanks, Moti. Thanks.